Okay, now we're going to talk about the O2 sensor. The O2 sensor is the basis of a closed loop. When you hear the term closed loop, that meaning when the computer and O2 sensor listens to each other, that's closed loop. That helps balance the air film. That helps balance the air film mixture. Open loop is when anytime the computer ignores the O2 sensor. When the computer ignores the O2 sensor, it's an open loop. Closed loop when the computer is listening to the O2 sensor, and that's based off the O2 content. So the O2 has to get, so to go in closed loop, we need the computer timer to run out, the vehicle operating temperature, and the O2 sensor sending a reliable signal back to the PCM, a varying DC signal, back to the PCM based off O2 content, then the vehicle goes in closed loop. Let me say it again. I don't know if I said it right. To go in closed loop, the computer timer has to run out. The vehicle has to be an operating temperature. And the O2 sensor has to be sending to the PCM a reliable signal based off the O2 content. When all three conditions are met, it goes in a closed loop. Now here's three different types of sensors. We're only going to talk about one right now. The top one, zirconium O2 sensor, voltage generating. Then you got titanium variable resistor type, and you got the air-fuel ratio type. The zirconium and air-fuel is the two populars right now, but zirconium is the top one. A zirconium O2 sensor generates its own voltage based off O2 content. The higher the O2 content in the exhaust system, the leaner air-fuel mixture, the lower the voltage. The lower the O2 content in the exhaust system, the higher the voltage. And the job of the PCM is to send an opposite signal back to the injectors. For example, if the car is running lean, the job of the PCM is to add fuel. If the car is running rich, the job of the PCM is to subtract fuel. And it cycles back and forth, balancing out the air-fuel mixture. That's why they call it closed loop. It's based off the O2 content from the exhaust going through the O2 sensor into the PCM. And here's a reliable signal. You got 0 to 1. The voltage on the sensor should be varying between 100 and 900 millivolts. On the older books, they said 200 to 800 millivolts. Now they're saying somewhere around, right now we're going 100 to 900 millivolts. 450 millivolts is the threshold. Anything above 450 indicates a rich condition. Anything below 450 and below indicates a lean condition. When I say that, that's a condition to the PCM. And the PCM job is to add or subtract fuel. For example, if I'm here at 200 millivolts, to the PCM, that's a lean condition. It is to drive the signal up. That means it has to add fuel to cross this threshold. Once it's on this side, the O2 sensor is going to see less O2 content. A rich air-fuel mixture signal goes back to the PCM, meaning a higher voltage above 450 millivolts. And now the PCM job is to drive back lean again. Go back down, up below this threshold. And the cycle repeats itself. That's why they call it closed loop. It tries to balance the airflow mixture based off the O2 sensor content and signal to the PCM. And here's the PCM. You can see here we got a upstream O2 sensor. Sensor input 1 Here's the ground. That's the O2 sensor symbol. Input to the PCM. This side's the heater circuit. But this input to the PCM, that's the voltage the PCM is looking at to help balance the airflow mixture. And keep in mind, that voltage is based off O2 content to help control the air-fuel mixture on fuel injection cars, carburetor cars. Its whole job is to keep it in closed loop to balance the airflow mixture. Alright, let's go to the next sensor now.